વિદ્યાર્થી મિત્રો, લક્ષ સ્કૂલ ઓફ સાયન્સ બામણમાં ઓનમાં ફરી એકવાર આપણું સ્વાગત છે. આજે આપણે થોડીક સ્કૂલની યાદ કરીશું. ઘણા દિવસ થઈ ગયા સ્કૂલ જોઈને. આપણો ઓનલાઈન અભ્યાસ ચાલી રહ્યો છે. થોડીક સ્કૂલની માટીની સુગંધને અહીં આપણે જોઈશું તો મજા આવી જાય. તો ચાલો સ્કૂલની ઝલક જોઈએ. આપણું સ્કૂલનું આ સિમ્બોલ, આપણી આ સ્કૂલનું બાહ્ય દેખાવ કેટલો સુંદર છે. જો ભારત માતા સાથે આ આપણું એન્ટરન્સ. અહીંથી તમે અંદર સ્કૂલમાં વારંવાર જાઓ છો અને યાદ આવતી હશે બધી. કેટલું સુંદર અહીં લાગી રહ્યું છે. આ આપણે હોલમાં બેસીને પ્રાર્થના કરીએ છીએ, ભેગા થયા છે, મિટિંગો યાદ આવે છે કશું? હાલના શબ્દો નિલેશભાઈ ને આપણા વાતો બધી તો બધું મિસ કરી રહ્યા છે. તો થોડુંક આજે આપણે એને દિલથી યાદ કરી લઈએ એવી ઈચ્છા થઈ. જાત જાતની એક્ટિવિટીઓ આપણે કરીએ છીએ. આ બધું ખૂબ જ યાદ આવતું હશે. પ્રવાસો હવે તો આ વર્ષે ભૂલી જવાનું છે. આ બધું રમતો સ્કૂલને આ રીતે આપણે યાદ કરીએ અને પછી ભણીએ તો મજા આવશે. Welcome dear students to Lux School of Science, and this time today we are going to talk about chemical reactions of amine compounds. Dear students, chemical reaction of amine compounds can be done in several manners, and those manners we have already done in previous videos. For example, we have completed acidic or basic character of amines. We studied about basic character of amines and how basic characters are important for that. Thereafter we have talked about the carbonamine test. Carbonamine test was also very important. For then after we have talked about then reactions with the nitrous acid and then with Hinsberg reagent, and that was the topic of our study. Now today we are going to talk about the different thing about the amines, and this different thing is nothing but with the heading electrophilic reaction. Electrophilic reaction. So electrophilic reactions is also the reactions involving with the benzene ring structure. Dear students, we know there are two kinds of reactions, nucleophilic and electrophilic. Here we are going to talk about the electrophilic reaction, and electrophilic reactions are nothing but the important like this. Here if anything is there, benzene ring is there, okay. In benzene ring, suppose one hydrogen is replaced by ammonia, that is amine group, then it is known as aniline. Actually this aniline has several names. It is also known as aminobenzene, it is also known as benzeneamine, okay. So this aniline is actually having some different character. For example, when we are talking about this aniline, at that time first the negative ion will develop here, then negative ion for their resonance structure, the second negative ion was developed here, and third negative ion was developed here. And that's why we can consider that NH2 is ortho, that is this position, and para, that is this position, ortho-para director. Okay, so when we are talking about anilyl compound, then this thing we have to think out that aniline compounds are ortho-para director, and when here anything is going to attach in that three place, this is nothing but the electrophilic reaction. So electrophilic reactions is nothing but the, from benzene ring we have to replace hydrogen by another thing, and this will be the interesting talk, okay. Now in previous lesson and previous thinking, we talk a lot about the electrophilic reactions, and then it is in electrophilic reaction we have talked about one bromination, nitration, sulfonation, alkylation and acylation. These 5 reactions are there. We are going to talk regularly about that. Which 5 reactions are there? We are talking regularly about that. Are nothing but the one was okay. Nitration, bromination, chlorination, fluorination, acylation, alkylation, sulfonation. These are known as the electromeric reaction. And dear students, today we are going to talk about that. So our first target to talk about is nothing but the bromination. Keep remember the amine compounds are ortho-para director. Okay. So now here I am going to show you the first reaction about this, and that will be interesting. So bromination, in that case first we have to take aniline. So I have taken here aniline, and for that bromination purpose I am taking Br2 water. Br2 water, that is the thing we need. So Br2 H2O, and the reaction will be occurred here, and instead of ortho-para position, the condition is that here Br will be go, here Br will be go, and here also Br will be go, and that's why we can say 2, 4, 6 tribromo aniline is produced. So this is the difficulty. We know our knowledge is that only ortho and para combinations always we are finding, but here instead of these combinations we are getting 2, 4, 6 tri nitro and aniline. Okay, and that will be the different thing. So dear students, now what to do here? Here we got this. Instead of getting ortho-para combination, we are getting one combination. Okay, why this is happening? So the answer why this is happening is due to the very high reactivity of aniline. Okay, so high reactivity of the aniline is giving us this thing. So hope that you understand why instead of ortho-para position we are getting 2, 4, 6 dinitro-bromo aniline, because the aniline is high reactive, and due to that its high reactivity, what is happening, you know? Okay, when the reaction will start, and at a sudden, not by passage of time, this is going to do these all 3 places which are negative. So the electron is migrating here very rapidly, and everywhere ammonia will be done. So now here we have to control out the reaction, because the reaction is very rapid, and that's why this is happening. So now we have to control out the reaction, and to control out the reactions, what we can do? And that is the thing, okay, by controlling the reaction we can do lots of things, and that controls can be taken by the acetylation. First we have to do the acetylation of the aniline by acetic anhydride. So control of reaction can be taken out. Control of reaction can be taken out, and this control of the reactions will be taken out by the acylation reaction, and this acylation reaction is done with acetic anhydride. So here we are using acetic anhydride. So use of acetic anhydride will make everything different. So come on, let's study. So first aniline is again taken. Aniline is taken. And this aniline is firstly react with acetic anhydride, and the formula of acetic anhydride is CH3 CO twice O in presence of pyridine. In presence of pyridine. So this is the first step, and due to that first step we are getting this reaction. जो बहुत सिंपल થશે, અહીંથી H નીકળી જાય છે. ઓકે, આ બે હાઇડ્રોજન છે તેમાંથી એક હાઇડ્રોજન આપણે આ બાજુ લખી દીધું, અહીંયાથી H નીકળી જાય છે, and this is going to combine with CH3. So this is our reaction and its name. હવે આ જે છે આપણા પાસે N સાથે નીચે પણ છે અને N સાથે અહીંયા પણ છે, બે ફંક્શનલ ગ્રુપ એડેડ થયેલા છે N સાથે. So as N સાથે બે ફંક્શનલ ગ્રુપ એડેડ થયેલા છે, that's why this is known as secondary, and secondary amine, its name will be like this N. પહેલા તો આપણે N લખી દઈએ, પછી અહીંયા શું છે, ફિનાઇલ ગ્રુપ છે તો N ફિનાઇલ. ઓકે, અને અહીંયા બે કાર્બન છે, that's why acetamide, N phenyl acetamide. So it should be our first product where N phenyl acetamide will be done. Now with this we have to do bromination. હવે અહીંયા તમારે bromination કરવાનું છે. So here we will do bromination now with Br2 water, and due to that reason now para position, only the para position will be working out here. HNCONH3 CH3 ઉપરનો એમ જ રહેશે, અહીંયા તમારા પાસે bromination નો Br આવી જશે. Okay, so this is the thing that we can control ourselves. So here was not controlled out, but here only para position will be controlled out. But dear students, you will say, sir, ઉપર તો આપણને શું જોઈએ છે, એમોનિયા જોઈએ છે, અને અહીંયા ક્યાં છે એમોનિયા? ઉપર તો આપણને NH2 જોઈએ છે, અને here where is ammonia? Okay, so that can be done again with acid or base. આનું reaction acid base સાથે કરીએ તો here the answer will be there above NH2 and here Br. So like this only bromo aniline will be obtained, para bromo aniline will be obtained, or 4 bromo aniline will be obtained. So dear students, as the high reactivity of aniline is there, when aniline react with the Br water for the bromination, then 2,4,6 tribromo aniline will be produced. Now this will be the control by acetic anhydride. When the aniline is firstly react with the acetic anhydride in presence of pyridine, at that time first intermediate compound N-phenyl acetamide will be obtained. Now this is reacting with bromination, reacted with bromine to get brominations, and we are get at para position bromine, and then after to bring back the aniline we will have to do reaction of this thing with H plus or OH minus, that is the acid or base. So I now hope that you understand the bromination process and control bromination process, and that will be the control bromination process is important for the examination purpose. Okay, so after bromination now we are moving ahead in electrophilic reactions. Okay, and that electrophilic reaction is also very interesting, and its name is nitration. Generally, our knowledge says that nitration is nothing but the nitration can be done by using concentrated HNO3 and concentrated H2SO4, and by the nitration we will get nitro product. Okay, so now here let's study the nitration of aniline can be done in this pattern. So here again we are taking aniline, and this aniline is react with concentrated HNO3 in presence of concentrated H2SO4. And dear students, here we have to manage also temperature. 288 Kelvin temperature should be managed out. Okay, and due to this reason the product is very surprising, because again aniline is very reactive, and as aniline is very reactive, the product is different here. And what is the product? Come on, let's see. First product is nitrocum at ortho position. Second product is NO2 come at meta position, and third product is also there. So third product is also nitrocum at meta position. So here you can see that due to the nitration, NO2 is entering at different position, and these positions are having special percentage. Okay, the maximum percentage is with para position, 51 percentage. The para nitro aniline is produced. Okay, in 47 percentage meta nitro aniline is produced, and at 2 percentage the remaining 2 percentage will be the ortho. Why it is happening? Actually our knowledge says that aniline is ortho and para direction, but here we can say the 47 percentage of nitro meta position. So this is not good. Okay, so that make us that every time whatever the concept of ortho para positions is not working here, so we have to think furthermore about that. And what we can think furthermore about that? Come on, let's study. Here also, to get para position intact, we will control the reactions. And how the reactions will be controlled out? See, the reactions will be controlled out here again as the previous method. So controlled reaction can be done as previous manner, and that manner I am going to show you. Again aniline is taken, and this aniline is reacted with acetic anhydride, that means CH3CO twice O in presence of pyridine. Okay, in presence of pyridine, and due to that reason the first intermediate product as usual NHCOCH3, that is N-phenyl acetonamide, and then this is reacted with the concentrated HNO3 and to produce the para position NHCOCH3, and at para position the NO2 will be entered out. Okay, and then after again H plus or OH minus is taken. At that time H plus or OH minus is taken, and we get the back aniline, and this will our story to get para nitro aniline. So dear students, now you understand by using of acetic anhydride we can control the reaction. But here question arises in your mind, why acetic anhydride can be control the reaction? So because of this reason the reactions will be controlled out, and the reason is this. Actually we have NH double bond O CH3. Okay, this is the topper part of the aniline. Okay, here we have lots of things, and અહીંયા કોણ હોય છે? phenyl group હોય છે, benzene હોય છે. Now this will be controlled out. This can be controlled out. The double bond is here donated out. Okay, and here also it is donated out. So what will happen? This will be changed out in this practice. અહીંયા હશે double bond will come here, this will become single bonded, and this become minus, this become plus, and this is the resonance structure. Two resonance structures are there, and due to that two resonance structure, the another resonance structure of the benzene will be rapidly moving, will be slown out due to this two resonance structure, and that's why we are getting para. So remember this, it is important for examination. Okay, so due to that resonance structure the reaction is controlled out. ચલો, તો હવે આટલી સમજ પડી ગઈ હોય તો હવે આપણો નેક્સ્ટ ટાર્ગેટ છે, and that next target is nothing but the sulfonation. So third one we are going to talk about is sulfonation. So sulfonation, every time we used to say the sulfonations can be done with the H2SO4, and this H2SO4 will make everything different. Actually here also we will have some problem, but which kind of problem will be arise here, there we are going to talk now. So again for sulfonation we are taking aniline, and for sulfonation we are using H2SO4. Generally it is found when sulfonation is done, then this H2SO4 is take any positions of the meta or ortho. But instead of these electrophilic reactions, here first anilinium hydrogen sulfate ion is produced, salt is produced. So here HSO4 will go here, NH3SO4, NH3SO4. It is also go there. Okay, so here we can write NH3HSO4 also. So this is positive and this is negative ion. Okay, so first instead of H2SO4 will not go with the electrophilic reaction straight away, it will go with the nucleophilic reaction first, and then after if it is heated from 453 to 473 Kelvin temperature, 453 to 473 Kelvin temperature, then 1 molecules of water is removed, and due to that reason the production will be NH2 and here HSO3 is produced, and that will be at the para position. Okay, and that is nothing but it is known as sulfonilic acid. It is known as aniline sulfonilic acid. Okay, and this sulfonilic acid sometime it is also can be convert into the zwitter ion. So this we can be convert into the zwitter ion. You know what is zwitter ion? So zwitter ion is nothing but the here one hydrogen will move here, NH3 plus, and here SO3 minus. This is known as zwitter ion. So dear students, this is our story about the, and this will be the last topic of chemical reactions by aniline. Okay, electrophilic chemical reactions. So we will meet tomorrow with new video. Up to that, be happy.